So what this wants you to do is to work out the formula for the different acids using this information here. Okay, so if I do the first one with you and show you how it goes, and you can try the others. So in this first one, we've got hydrochloric acid, so that contains hydrogen. Now the chloric bit means it contains chloride. Okay, and the information that I've written down here has come from this information here, giving me the charges on the ions. Because hydrogen is a +1, it wants to make one bond. The chloride ion is a -1, so it wants to make one bond. We check that we cannot simplify these, and we can't, so we swap them over. So we end up with HCl as the formula for hydrochloric acid. Use the same approach. I will put into here for you the formulas for the ions, and then you can work out how many bonds they form, and therefore the final formula for the acids. This one is hydrogen with a sulfate, as we've got there. You do the same on the alkali side. So if I just show you sodium hydroxide, so sodium hydroxide is a sodium ion and a hydroxide ion. Again, I'm getting this information from here. So sodium ion is +1, so it wants to make one bond. A hydroxide ion is -1, so it also wants to make one bond. You cross them over, so the formula for sodium hydroxide is Na and then OH. Okay, now you should be able to work out, I'll put those in for you as well. So that is Mg2+ with hydroxide, OH minus. And here you've got calcium is a 2+ and OH minus. So you should work out the formulas for all of those, and you can check the answers once you have done that. And you should then be able to say, what do all the acids and then all the alkalis have in common? So once you've done that, this would be a good point maybe to pause the video and let you do that. And then when you're ready to start looking at the next section, we will go through that as well. So in this next section, we are talking here about neutralization. And let's just remind ourselves that neutralization, we'll write it here, is when you take an acid and an alkali and react them together in the right amounts, so they completely neutralize, cancel each other out. And the product is always going to be a metal salt and water. And that reaction, as we've said, is neutralization. And basically what we're taking is the acid contains hydrogen ions and the alkali contains hydroxide ions, and we're making those two react together to cancel each other out in this reaction. So you should be able to fill in this little section here based on that discussion. And then this is a little test of memory. So what is meant by the words base and alkali? So base and alkalis, these are the opposites of acids. They contain hydroxide ions, and an alkali is a soluble base. So an alkali is a soluble base. Okay, again, good point to pause the video, fill in the bits that we've talked about, and then when you're ready to start, we'll finish the next little bit, and there's a bit more for you to do in this next bit. So in this bit now, we're looking at the general equation for neutralization, and to help me, I'm going to change the color of my pen a little bit here. So we take an acid, we react it with an alkali or a base, and in that reaction, that neutralization reaction, that is going to make, I'm going to write this in this way, a metal salt and pick a different color, water. Okay. Now the reason I've done metal salt in two colors is because the second name of the salt comes from the acid, and the first name of the salt comes from the alkali, and that's why the color coding is there to help us to do this. Okay. Now the alkali, or the base that we react, can be any of these type of chemicals. So it could be oxides, they could be metal hydroxides, or metal carbonates. I'm giving examples of each one of those types of chemicals here. So naming the salt, this is what you're going to have a go at. Naming the salt. If you're going to name the salt, the name of the salt depends, or the second name of the salt depends on the acid we use. So if we use hydrochloric acid, we always make a chloride salt. If we use sulfuric acid, we make a sulfate salt. And if we make nitric acid, we make a nitrate salt. Okay, so let's have a go at an example, and then you can try one of these yourself. So my acid is hydrochloric acid, which, if you remember from earlier on, is HCl. And we're adding this to sodium hydroxide. Again, we did this formula earlier, so it's NaOH. So if I just remind myself, this is obviously the acid because it's hydrochloric acid. This is the alkali, and we are going to make a metal salt and water. Okay, so the metal salt, because it's hydrochloric acid, if we come back to this, hydrochloric acid makes a chloride. So the second name of the salt is the chloride. The first name of the salt comes from the metal. So the first name is going to be sodium. The metal in the alkali gives us that first name. And then we have plus water. Okay. You want to fill some formulas in here. So water, hopefully we remember, is H2O. Sodium chloride, if you can't remember the formula, not a problem. Sodium lives in group 1, so it's a +1 ion. Chloride is in group 7, so it's a -1 ion. They both want to make one bond. We cross them over, so you end up with Na gets number 1, Cl gets number 1, so it's just NaCl. So there's sodium chloride. Then just check if it's balanced. This one is balanced because there's 2 hydrogens, and there's 2 hydrogens here. There's 1 chlorine and 1 chlorine. There's 1 sodium and 1 sodium. And there's 1 oxygen and 1 oxygen. Okay, so what you can now try, here are some more reactions of this type. So each one of these is obviously a different acid. Remember, the name of the acid is the second name of the salt. So you can work out the salt in each of these, and the first name comes from the metal that we have used. Then try to work out the formulas for these. These ones have already been in the tables above. I'm going to tell you that you will need to know that magnesium is a 2+, and sulfate is SO4 2-. So when you come to work out the salts, put that information there, that information will help you to work out the name of this salt. Okay, this one here is going to be Li+ and NO3-. So to work this one out, you need that information. And the bottom one is Mg 2+ and Cl-. And again, use that information to work out the formula and the name for this salt. So again, that's probably another good point to pause, have a go at those, and again, check the answers when you've done it, because the answers can be shared with you to check and make sure that we're getting those correct. So we want a word equation and then a formula balanced equation underneath. So pause the video. Okay, the last little bit here on this is working out here the general equation for this reaction. So If we remember that hydrochloric acid is HCl, potassium hydroxide is KOH. What's the name of salt going to be? Well, the first name comes from here, so that is potassium. The second name is a chloride because it's hydrochloric acid. So there is a chloride, and then we have plus water. All right. Formula here for potassium chloride is KCl, and then water is H2O. So this equation, let's double check. There's one chlorine and one chlorine. Two hydrogens, one potassium, one oxygen, so it's balanced. Okay. It now says split the compounds into ions. So if I split HCl, HCl will form two ions, a hydrogen ion and a chloride ion. Potassium hydroxide will form two ions, K plus, OH minus. Potassium chloride is K plus, Cl minus, and water is just H2O. Water doesn't form an ion, so water is just H2O. Now then, what we want to do is look at this, and we're going to look and see which ions have not changed, and I'm going to remove those from the equation because they looks like they haven't changed and therefore they haven't taken part. They are called spectator ions. So if you have a quick look at this, let's pick on the chloride ion here. So if we've got chloride ion here, I've also got a chloride ion here. So the chloride ion is appearing on both sides and it's exactly the same, Cl minus, Cl minus. So I'm going to get rid of that and ignore it from the equation. If I look at the hydrogen ion, H plus, well on this side I haven't got a hydrogen ion, so that needs to stay in the equation because that is not present here, so it's changed. I have to keep it in because it's changed. This side I've got K plus, I've also got K plus here, and they're both exactly the same as each other, so we can get rid of those two. My OH minus, my hydroxide ion, is here, and there isn't a hydroxide ion here. This has actually been used to form water, so that's changed. So again, I'm going to keep that in. Water is water, it doesn't appear here, so that's changed. We'll keep that in. So what I'm going to do now, let's just write down what's left. So I've got H plus, I've got OH minus, and here I have got H2O. This is called the ionic equation for neutralization because these are the ions involved that haven't changed, and we can simplify this equation to form this equation. So we've got the hydrogen ions from the acid reacting with the hydroxide ions from the alkali to form water. So again, pause the video there and you can fill that bit in as well. Okay, we'll pause there. You don't do anything below here. We'll do that when we come together again, and there's some other work for you to complete in class.